All right, so this time around we're talking flowcharts, and this is more of an aside. This is something that I want you to be aware of, but it's not something that is going to come back to you in an assignment. However, these can be an incredible tool for planning out your code, and you will see these come up when you get into your software engineering classes and when you get out into the workforce, because not only do these come in handy for plotting out your code, flowcharts have a number of applications as a business process tool that help you figure out, okay, what's the best route to get from the beginning to this process to the end of this process. So we're going to dive straight in. We're going to look at exactly what a flowchart is, the symbology behind it. We're going to see the translation from verbal instructions to flowcharts and then from flowcharts to code. So we're going to jump straight in. What is a flowchart? Simply put, it is a diagram that shows how a task flows from one step to the next. If you look at something like a list of steps, you'll see that you could easily map it to a diagram that shows, okay, this step inexorably leads to this step leads to this step. If something goes wrong, this step might jump you back to step 2 or step 1 or something like that. And it just shows essentially the roadmap. Like it said on the title slide, it is a roadmap for your processes. It has many applications in programming. It is one of the many tools that we use in the software development phase when we're not writing code, but rather writing things that show what the code is supposed to do. There's going to be branching points. There's going to be different shapes and colors to indicate different kinds of steps and structures. And this is no more apparent than in programming. Now, when we're talking about flowcharts, there are several tools that we can use to create said flowcharts. I use one called Flowgorithm, which is entirely centered around programming. There are flowchart creation tools that are more generalized, that are more focused on business process, and it is up to you to choose which one works for you. You have a few listed here that I have had experience with and can recommend. Of course, there's Flowgorithm. There's also Microsoft Visio, which you have access to as a JSU student. And then there's Visual Paradigm, which is a free application that I have used in the past. It's a little bit complicated compared to Flowgorithm. It does a lot more. It's a lot closer to Microsoft Visio in its flexibility. Both of these applications do all kinds of different diagrams. But these are the 3 recommendations I can give for your choice of flowchart application. So, when we talk about the symbols in a flowchart, there really is no set standard. So as long as you are being consistent and using symbols that make sense, it is no problem. This here is my choice of Flowgorithm theme. I use the Star Trek LCARS theme because I am a nerd. And you can see here, each of these is labeled to do something different. This first parallelogram in orange, that's for input, and the purple parallelogram is your output. The rectangle in orange is a declaration, and then the simpler rectangle that's kind of a light tan, that's your assignment. You can think of that as like your equals operator, and so on and so forth. Flowgorithm does have some limitations in the kind of loops it supports, the kind of other structures it supports. So you might have to get a little creative. You might have to use something else depending on your needs. And it also is a one-way in, one-way out structure. So there's no multiple ways to end a particular algorithm. And while I've got you here on this slide, I do need to talk about algorithms. What exactly is an algorithm? You've probably heard the term floated around a lot, especially if you are a YouTube regular. An algorithm is quite simply a set of instructions to follow. Think of it like baking a cake. You have your ingredients, that's your inputs. You might also hear it as throughput. But your algorithm would be your steps, assemble your dry ingredients, mix your flour, your baking powder, your whatever else you need, cocoa powder. Then assemble your wet ingredients, your sugar, your eggs, your oil, and so on and so forth. Your milk. And then you bring them together and you fold them into each other. Then you pour the batter into your pan. You put it in a preheated oven for a set amount of time, and out comes a cake. That is an algorithm. An algorithm is not something specific. It can be any set of instructions. It's a very common tool in programming to think algorithmically, to think in that step-by-step process. And as we go along, as we get more and more complex problems to solve, you're going to see more and more mention of algorithms and more need for algorithmic thinking. And this is one of the reasons why we use flowcharts. These help to support algorithmic thinking because they take those thoughts and put them into a nice, easy-to-read diagram. So remember, when it comes to the symbology, to use a consistent set of symbols that makes sense to you. Now let's move on to the conversion process from written instructions to some kind of chart to show the steps. So our first one here is just a simple process that runs something to the screen. You could think of this like your Hello World, your original one that you did way back when. So in Flowgorithm, we have the main that indicates the start of our code, because usually in programming languages, your beginning point is a function that you create called main. It's not the case in Python. Just remember that, because here main is where our steps begin. So what are we being asked to do? We're being asked to create a string called x, give it a value, and print the value. So you see, at first, we have our declaration, string x, our assignment, x equals hello world. And then immediately after that, you have the function call, print x, and then end. End just marks this is where your code ends. This is where it stops. And of course, Flowgorithm is a bit simple. It doesn't necessarily support all the constructs and all the multi-chart niceties that Visio and Visual Paradigm do. So it's meant more for simple explanations. If you are actually doing a design for a project, it is probably not best that you use Flowgorithm. This is more for an educational tool than a practical tool. So if you are using these kinds of tools to help you complete your assignments, which I do recommend, then I recommend you use Visio or Visual Paradigm. Moving on to part 2, we are given a number x. If x is even, double it. If x is odd, triple it. And then we want to print it to the screen. Next week, we're going to talk about conditional statements. And this is an example of how they work. They evaluate a true-false statement. If it's true, we go one way. If it's false, we go the other. So if we look here at our example, we have the string x, or the integer x, pardon me. We are giving it the dummy data of 5, and we are asking if x mod 2 equals 0. Remember what I said about the modulus operator. It performs a division with the two operands and reserves the remainder. Therefore, if x mod y equals 0, then x is divisible by y. So in our case, it is false, so x equals x times 3. And then we reach the end of our conditional statement, and we're going to say print x. In this case, this bit of code, if we were to write it out, would print the number 15. Moving on to our more complicated example, we are to determine the greatest power of 2. less than or equal to a given number. Print the result, counting up each iteration. If input number is negative, we print an error. So you see we have multiple instances of branching code. We have our conditional statement and we have a loop. So we have our integer, which is number. We are giving it the value of 1024. We then have our exponent variable. That is also an integer that we initially set to 0. And the first thing we need to check is that x is a non-negative number, or that number is non-negative, pardon me. And if it is not, if it is negative, then we print an error and our program ends. If it is, however, positive, then if number is greater than or equal to 2, then we follow a process to count up our exponents. So the first thing we do is we divide number by 2, then we increase exponent by 1, and then we print exponent. And then when we're done, we'll see, in our case, it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It stops at 10 because 1024 is 2 to the 10th power. And then there's our solution. And now the part you've all been waiting for, turning it into code. You can see we follow the same steps in our Python code. This first one should look extremely familiar. Just replace x with message, and this is exactly the same. Here's an example of a conditional. If x mod 2 is 0, double it, else triple it. And then we print x. And then lastly, our while loop. We say number is 1024, exponent is 0. If number is greater than or equal to 0, then we do a while loop. While number is greater than or equal to 2. We do those 3 steps we mentioned in the previous slide. Otherwise, we print our error. Number must not be negative. Now, I don't want you to worry about if statements, while loops just yet. I just need to use these as examples of how flowcharts work. We will see more of these as we go along. I will continue to use them as a teaching tool for at least a little while. So, like I said, flowcharts, these are how we break things up into steps that we can visualize before we write code. Doing this helps to write more effective code because you go in with a plan instead of just trying to brute force something. So, no assignments for this. When I come back, we're going to do conditionals, and we're going to really start seeing our code expand into more complex problems and solutions. So, stay tuned for that.